Good afternoon, and thank you for joining us for today's webinar. Are all power supplies really the same? My name's Jeff Rushton and I'm the Chief Technical Officer at Alarm Corp, and I'm also joined today by Alarm Corp's Business Development Manager, Diane Brazil.
Thanks, Jeff. It's great to be here.
Okay, just before we get started, and for those that haven't joined us for a webinar before, I'll just run through some main points. Firstly, you'll see that you're muted, and you're going to remain muted for the remainder of the webinar. And also, just to make sure that you can see and hear me, if you wouldn't mind using the raise hand icon, just to see that I can see you guys are beautiful. Okay. If at any time during the course of this webinar you have any questions, please type them in the question tab, hit the send button, and at the end of the webinar we'll go through and answer those questions. So for now, in order to get started, I'll pass you over to Di, and we'll run through it.
Thanks, Jeff. Why a cheap power supply? It could cost you. Like most things in life, the cheapest isn't the best or even a viable alternative. What to look for or avoid when it comes to your power supply selection. Reliability. We know that poor quality power can equal poor system performance. With compliance, the market is flooded with cheap imports and the temptation to use them can be high. The implications are, can you afford to take the chance? Penalties are high. And Ohm's law, not just a theory. The information contained in today's webinar should be useful to everyone. I can see we have a number of integrators here today, and many of these points need to be considered rather than just selecting the cheapest product. We also have a number of specifiers here, and unfortunately power supplies get overlooked simply because it's not a major component to specify. Alarm Corp only sell power supplies from Tactical Technologies, who design and manufacture products in Sydney and have been a major manufacturer for many years. We'll be comparing the features of these against the cheaper imported products.
Okay, very good. We know that, I suppose, 2020 hindsight is a wonderful thing. But by specifying and installing quality power products, integrators can save themselves more than just the initial outlay. Think of your reputation, stress, and repeat business. So let's look. It's often asked the question when the subject of system design arises, and the answer becomes sort of self-evident after the first failure. Any dollars saved by poor quality, let's call them cheap, power supplies, is more than completely lost when they have been prematurely replaced. Even if a supplier provides a replacement at no charge, we all know the integrator must still pick it up or wait for it to be delivered, then send someone out to fix it, travel on site, and undoubtedly you've got a very unhappy customer watching over your shoulder. And I guess this is bad enough as it is, but it can be even more expensive when the power supply doesn't actually completely stop working. When it doesn't work, it's easy. In a CCTV system, everything goes black. But when it's operating intermittently, and that's more than often the case, the quality of the output voltage can be sufficiently poor to cause either poor picture quality in a CCTV system or intermittent or unreliable performance for an access control system. So think that the cost of a power supply is generally a small percentage of the overall system cost or hardware cost, yet it's a simple cost-saving choice, in other words, installing a cheaper or inferior power supply, that can sort of have far-reaching ramifications. And it doesn't matter how much you spend on the rest of your system. If your power supply fails, so does your system.
When it comes to compliance, we know that the Australian electronic security market is flooded with poor quality, low-cost power supplies. Although the temptation is there to use these devices, can you afford the consequences? The importing, selling or installing non-complying electrical goods carries very extremely harsh penalties. We can see the fines here are quite high for an individual and for a corporation. All tactical power products have been tested and certified by Australian testing authorities to comply with or exceed Australian standards, making them suitable and legal for use in Australia and New Zealand. Do security power products that you install or resell comply with Australian electrical safety and EMC standards? We know that tactical products meet or exceed Australian standards. We've seen in recent years there's been a marked increase in the number of security power products sold which do not comply with Australian standards, either electrical safety or EMC. Let's face it, most security power supplies look like simple metal boxes and offer the cheapies outwardly appear to be similar or the same as genuine compliant products. It's only upon closer inspection or pointed questioning of your supplier as to the legal compliance status of the item in question that the real picture emerges. Very often these inferior products not only fail to comply with even basic state safety standards, but due to the poor quality of components and overall design, they represent potentially life-threatening electrocution and fire hazards. Products which fail to comply with Australian standards are potentially electrically unsafe and are more susceptible to causing harm to people and property. If you're an installer, contractor or distributor who buys or installs electrical products that don't meet Australian standards, you could face fines plus civil and or criminal action.
Okay, I guess what are the legal implications though? Under Australian law, whoever initially imports a product is legally recognised as the distributor of that product. They are also directly liable should the product fail or cause harm to anyone. And certainly if proven that an installer knowingly installs products that don't meet Australian standards, they can be deemed liable for any damage or death caused by these faulty goods. If the installer's conduct does not meet reasonable standards and there's a high risk of causing death, as could be a case of an example of a power supply without a mains lead, that there are severe penalties as well as potential criminal charges up to manslaughter. So simply selling, installing or importing non-complying electrical goods could render you liable for substantial penalties, and certainly any resultant loss or damage, it won't be covered by insurance, and this could lead to potentially millions of dollars worth of risk depending on the severity or the loss. So I guess in red we're asking, so ask yourself when weighing the initial cost saving against the potential for, let's say, at best poor performance or certainly at worst potential penalties or legal action. So we've spent a little bit about the legal stuff. Let's talk about more about the products or the features of power supplies. We've got here the concept of providing multiple independent short-circuit protected outputs on a security power supply. It's certainly not a recent invention. They've been doing that for years. The aim of a distributed output system is to ensure that if you have a short circuit or an overcurrent situation, it might be a faulty camera or it might be let's say a deliberate form of vandalism. If that occurs on one output, obviously it shouldn't have any impact on the system operation or any of the devices connected to the other outputs. Power supplies typically do this with the old glass fuse or potentially a thing called a poly switch on each of the circuit runs. There's pros and cons for using either of those two ways, such as potentially temperature sensitivity or over current trip lagging. But notwithstanding any of that, the use of fuses or poly switches, both of those can still be problematic on a power supply installation. In particular, when it's used with devices that have a very high inrush startup current, things like electric locks, PTZ cameras, IR illuminators, products of that type. In those cases, it's necessary to configure the output with a fuse or a poly switch with a rating high enough to provide the required startup current. In some cases, that could be maybe 400 times or 4 times what is listed in the manufacturer's details. And obviously, we want that to not trip the circuit. But in doing that, it's common to have a situation where the system starts up and it appears to operate correctly, but when a short circuit occurs, by a failure or vandalism or by whatever means, the entire power supply will shut down before the individual overcurrent protection trips in, and that results in every device on that power supply failing and stopping. We can minimize that by a conservative selection of the main power supply, that is ensuring we have enough power to adequately supply the inrush current and the trip protection and then the normal current on all of the devices running, or by careful selection of the values that we put in for the fuses or the poly switches. That's all well and good in theory, but certainly, unfortunately, these calculations are quite often either they're not performed, or if they are performed, they're not correctly implemented. And worse still, is it's generally not discovered until, something bad happens, the thing's gone down. And therefore, everything on that power supply stops working. Whilst the situation is certainly not unknown, it's generally not well understood, and up until not that long ago, it hasn't been easily addressed. So the heading on both of these slides says active electronic overcurrent protection. This is a term or a function that Tactical developed and has a patent out on, that's connected to each of the individual outputs, as well as having the conventional overcurrent protection on the main power supply. It's featured in its recent 24-volt series models, and this overcurrent protection is designed for high security or high reliability applications, such as places like detention centres and jails. AEOP is accurately configured for each output, and it yields a robust operational solution previously unavailable in the power supply industry. The active electronic overcurrent protection will be rolled out as an option on a range of other high-end tactical DC power supply models. Okay, so you've got a number of devices. You've got cameras, you've got locks, detectors, etc. And you need to terminate and power up. This might sound pretty basic, but I think it's important. You could just connect them all to the same set of terminals on your power supply, just parallel them all up. Might be a bit of a mess, might be a little bit time consuming, but ultimately your solution's going to work. So apart from the messy installation, the trouble is future troubleshooting of cable faults or unserviceable equipment is going to be extremely difficult. But beyond all of that, the biggest problem is if all devices are connected to effectively the same set of terminals and a short circuit or a vandalism or anything was to happen on one of the cable runs, then not only one device will stop working, but all the other devices connected to that power supply will stop working as well. So instead of an isolated problem, you've now potentially got the entire system failed. The most logical approach to addressing any of this is to use a power supply with a built-in power distribution module. Not only does it make terminating the job a lot easier, but it should ensure that a failure on one device or its cable run doesn't result in a failure of the whole system. Tactical have tested a variety of suppliers around in the marketplace, and they've found that there's some models that are of such a poor quality that even on their PDMs you get a 2 volt voltage drop, and that's even before you consider voltage drop in cable or terminations or anything else. So you're already starting well behind the 8 ball when using inferior products as such like this.
Okay, a very common question, AC or DC, which one should we use? We know that most CCT cameras are used off a 12 volt DC or 24 volt AC. It starts out with the simple fact that if you double the operating voltage, you halve the current required, or if you halve the operating voltage, you effectively double the operating current required. So a camera with 6 volts will draw approximately 500 milliamps at 12 volts or 250 milliamps at 24 volts. This is before we factor in the voltage drop caused by cable gauge, length of run, termination resistance, etc. Assuming that we stick with industry best practice, which recommends that you do not connect more than 70 to 80% of the rated load of the power supply. In this example, in order to power 16 of the cameras, you would require a 10 amp 12 volt DC power supply or a 5 amp 24 volt AC power supply.
Okay, Di, if we take that just a step further, there's a difference between 12 volt DC and 24 volt AC supplies, apart from the obvious. Due to the manufacturing complexity though, DC supplies can be up to 3 times more expensive than the equivalent AC supply for any given current rating. So, i.e. if you've got a 12 volt 5 amp supply, that can be up to 3 times dearer than a 24 volt 5 amp supply. So in the previous example, if we select 12 volts over 24 volts, we'll need a supply that potentially is up to 6 times more expensive. That is, we need twice the current, and that power supply potentially is 3 times more expensive. Now, I guess if it was as simple as that explanation, you know, we're all going to be installing 24 volt AC power supplies, and all the 12 volt DC ones will be left in the truck. But you knew it wasn't going to be that straightforward, didn't you? So, with 12 volt DC regulated supplies, there's a couple of things that we need to consider. First is that it's a good quality 12 volt supply. They're designed to deliver a constant regulated 12 volt DC. You should be able to measure this from a no load, that is when nothing is connected, through to a full load, that is if it's a 5 amp supply, then you have got a 5 amp load on it. So, and that's regardless of the input main voltage, so in our case typically 240 volts. Note that the main supply voltage can both vary up and down depending on your location, your cabling infrastructure, your local load, God, even the time of day can affect your mains voltage level. If we look at a 24 volt AC supply, they've got no internal voltage regulation at all. In fact, the only time that you'll be able to measure approximately 24 volt AC out of a 24 volt AC supply is when both these two factors are met, and that is the incoming mains is 240 volt, not a bit lower, not a bit higher, and when the connected load is at the maximum rating for the transformer, so that you do have 2 amps being drawn on a 2 amp power supply. If the output load remains stable, but the incoming mains voltage varies up or down, then the output's going to track up and down in the same way. So if you've got 230 volts coming in, you're going to have 23 volts come out. 255, you're going to have 25.5 volts coming out. And likewise, assuming that the mains is still 240 volts, if you have a 24 volt 10 amp power supply and you've only got a load of 1.5 amps, and you can do this typically in cases where you put in a larger supply to cater for maybe future expansion or future devices, then what happens is the output voltage could be, maybe it could be 26, it could be 28 volts, depending on the transformer quality and design. Now, if the incoming mains rises to, let's say, 255 volts, then the output voltage potentially on that power supply could be over 30 volts AC. And that could lead, depending on the equipment, to long-term damage. So in summary of this, so depending on your installation requirements, a 24 volt power supply is generally more flexible when it comes to medium to long cable runs. And the reason for that is Ohm law tells us that for any given equipment current draw and cable length, the voltage drop over the distance is similar, regardless of whether you're operating on a DC or an AC voltage. But however, if you've got the calculated voltage drop, let's just say the voltage drop over the cable is 2.5 volts, then a camera connected on 24 volt AC will probably work quite happily. So 24 volts minus 2.5 volts, you're getting about 21.5 volts at the equipment. That's probably still well within the equipment parameters. But if you're operating at 12 volt DC and you took off 2.5 volts, now you're left with 9.5 volts, which is probably under most equipment minimum voltage levels, and hence probably won't start up or won't work correctly. So in summary of this point, while there's a few exceptions, if the mains voltage is reasonably stable and your cameras can accept either a 12 volt DC or a 24 volt AC supply, then 24 volts is the way to go. It will give you better performance and it will certainly give you greater cost efficiency. Di, tell us a little more.
Disaster can strike when 12 volt DC is not actually 12 volt DC. When many installers in the industry talk about 12 volt DC power supplies with battery backup, what they actually mean is a power supply with 13.5 volt DC to 13.8 volt DC output. In fact, a large number of manufacturers describe their products as 12 volt DC with battery backup, when this can only be achieved by adjusting the output of such supplies up from 12 volt DC to 13.8 volt DC for charging. This may not seem significant and in fact may actually be advantageous for electronic locking and general security applications. But when it comes to some CCTV cameras, it can make the difference between a successful installation and one which systematically fails over time. The problem arises when the system appears to work perfectly at time of installation, but over the following weeks or months, cameras start to fail for no apparent reason, leading to customer frustration and cost to the installer for camera replacement. The worst case scenario is that many cameras may be replaced over time before the actual problem is discovered and rectified. The typical solution to this problem has been to replace the power supply with one which outputs a true 12 volt DC and forget about battery backup, opting rather for a larger UPS to both power the camera power supply and recording equipment. Less than ideal, to say the least. Some years ago, Tactical addressed this problem with the introduction of the SI series of power supplies. The SI series featured dual channel outputs, i.e. a true 12 volt DC 5 amp output to power cameras and a separate 13.8 volt DC output to charge standby batteries. In the event of a mains power failure, these supplies re-regulated the 13.8 volt DC from the battery to 12.2 volt DC, ensuring that regardless of mains or battery power, cameras were not exposed to greater than 12.2 volt DC, ensuring that camera operation continued during a mains power outage and camera life/operation was not compromised by excessive voltage. The SI series was discontinued in 2011, but fortunately this world-first dual-channel functionality continues today in Tactical's current lineup of 12-volt DC power supplies. Interestingly, Tactical believe that they are still the only security power supply manufacturer in the world to offer this functionality, and in fact the situation is even better with the battery charger capacity of the newer models being increased to almost double that of previous models. Substantial savings can be made using the Tactical DC series supplies with large standby batteries to power your cameras, resulting in a much smaller capacity UPS being required just to power your storage and ancillary devices.
Okay, let's go to the only semi-calculation bit of this exercise. When putting in a power supply, it's always good to perform at least some form of basic power calculation before specifying a power supply for your project. Seems simple enough. So once we've decided on the voltage, we just need to take into consideration the current draw from each device and add them together. So if we had an example, we've got 8 sets of Siemens PE beams at 13.5 volts. They draw 50 milliamps each. So we've got 400 milliamps of current. We've added now 22 Aratec PIRs at 13.5 volts, and they draw 10 milliamps each. So that's another 220 milliamps. So in total, we've got 620 milliamps of current. So under those conditions, a standard 13.5 volt DC 1 amp supply would be more than sufficient. Let's add some IR illuminators now. So now we've got 2 IR illuminators. They work between 12 to 32 volt DC, and they draw 13 watts. I won't read the next line. What? Well, it's a bit concerning now, because why don't manufacturers just refer to amps or milliamps for current consumption and leave watts to the car stereo guys? It's probably too long to go into here, but let's look at a simple way of estimating the current consumption in watts in amps or milliamps instead of the watts shown. So basically watts equals volts times amps. So if we know the wattage and the operational voltage, and in this case, an example, it's 13 watts, operating volt of 13.5, which is our power supply, we can estimate that each of these IR illuminators is going to draw about 963 milliamps each. So going back to our example, so we've got our 400 milliamps for our beams, our 220 milliamps for our PIRs, and now we've got basically 1926 or thereabouts milliamps for our illuminators. So the total current is a touch over 2.5 amps. So we're going to need to upgrade our 1 amp supply to say, I'm going to say a 5 amp supply at this time. But you're probably saying to yourself, well, industry standard says, you know, if we have 70-80% of the total load, we really should be able to get away with a 3 amp supply. And I suppose you're pretty right. We should be able to. The emphasis on should or but. But devices like IR illuminators, maglocks, drop bolts, strikes, PTZ, you know, heaters, etc., 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 the list goes on and on. We have to allow for a high inrush or a startup current on these devices. Unfortunately, in a lot of cases, this isn't going to be specified in the datasheet or instructions. And the inrush current can be considerably higher than the equipment manufacturer's stated maximum running current on a particular device. So we really do need to err on the side of caution, and a 5 amp supply would be probably the suggested supply, but a 10 amp supply would be even a better solution in this case. So in summing up what we've seen and what we've learnt today, important, check compliance. Look at the label on a power supply, check for its approval rating and its C-tick mark. Choose a respected brand product, and this will ensure the right reliability and the support of the product. Use distributed outputs when powering multiple devices from one power supply. Which voltage? Check to see if you can get away using an AC supply, both to save money and potentially to increase reliability, depending on the application. Do your calculations for a load. Make sure you allow for devices that have high inrush current when powered up, and if pricing is similar, try and pick an Australian manufacturer. Choosing a power supply is very much an afterthought while selecting, all the other products that go to make up a system today. But I suppose my parting comment would be, remember that we're in the electronic security industry, and unfortunately, without power, our electronics don't operate.
Would you like to know more? For more information, including brochures and data sheets, you can visit our website at www.alarmcorp.com.au. If you subscribe to Alarm Corp Pulse, you will automatically receive new product information. And if you register online at our website, you will receive full access to our e-commerce platform, including pricing, and you can also place orders online. To contact either Jeff or myself, our details here on screen, Richard Bell, our CCTV product manager, or Stephen Dinger, who is our Southern Region manager. We're now on Facebook, LinkedIn and Twitter. If you just search Alarmcom, you can follow us on any of those social media outlets. Alarm Corp will be conducting regular webinars for the remainder of the year. Every third Thursday we will be holding an intrusion-based webinar. Our next one is on the 20th of November. That's our last one for the year.
Woohoo! Oh, sorry, I didn't say that.
Thanks, Jeff. And can wireless access control really save me money? I'd like to think so. Every second Wednesday we have a CCTV webinar, and the next one is on the 12th of November. VMS storage design, what level of RAID is required? If you'd like to register for any future webinars or view any previous webinar, please visit our website and click on the resources, then webinars. For this month, when you attend one of our webinars, you'll have access to some special promotions we're running. For all purchases made online through our e-commerce platform, please enter the promo code OCTWEB14 during checkout to receive an additional 10% off your already discounted trade prices. This applies to nearly all of Alarm Corp's product range, with a few exceptions as listed here. CPAS, Sony and Verint apply there.
Okay, if you've had some questions, now's the time to type them in and hit send, and we'll answer them, or at least attempt to. So I might just wait a few seconds to see if any can come through. So we've either made it extremely clear or very baffling. Had nothing through as yet, which has to be a good sign. Okay, based on that, Di.
Thank you everyone for attending our webinar. We appreciate the time taken from your schedule to attend today and hope you found it beneficial. We look forward to seeing you at the next webinar. We hope you enjoy the remainder of your day. Goodbye.